Welcome back to Proximity Math. I'm going to go over the 2005 Aime Ii number 14. In triangle ABC, we have a 13, 14, 15 triangle. D is on BC with CD equals 6, and E is on BC with angle BAE, theta equal to CAD. Given that BE equals, so we have to find BE. If we let it be X, and since this is the 15 side, we have 6 being CD from the problem. So we have x and 9 minus x. We must sum to 9. First of all, we can divide this into, let 14 be the base, divide into two right triangles. That's a common trick for a 13, 14, 50 triangle. It'll give us the trigger ratios really easily for the angles. Alright, so we have a 5, 12, 13 triangle, and then a 9, 12, 15 one, which is a 3, 4, 5 triple. Okay, so we can find the sine of b, use the sine addition formula. Just take 5 13ths times 4 fifths plus 12 13ths times 3 fifths. Yeah, use the trig ratios of these two right triangles, and then you can easily find out. Next, okay, if you use law of sines, because we have two angles which are theta, so use law of sines on ACD with angle C, and solve for AD. Next, if you do the same with the other triangle which has sine theta in it, we get something in terms of x. We don't know what AD and AE are, but we do know the angles opposite them. I mean the sides of them, because we don't know the sine of the angle at D or nor E. Alright. And using law of cosines, because we have AC and CD at the angle C, it's cosine. And that's not true for any other place, which is why we can find, using law of cosines, AD. And even though 656 is divisible by 16, it's best to leave it as a vertical, because we're going to use it a lot to simplify. That's a good idea. Okay. Now, I'm applying law of sines and using basic algebra. We have found sine of theta. I just left out all the arithmetic and the time it takes. Alright. So now that we have sine of theta, we can solve for x somehow, maybe. We haven't used the fact that this side is 9 minus x, but we have used the fact that it's a 13, 14, 15 triangle. So maybe we can directly solve for x by finding something about this angle. And notice, since the sine of an angle is sine of 180 degrees minus that angle, the sine of BEA is the sine of the sum of angle B and theta. See? Okay. Now, law of cosines on this uppermost triangle again. We have x over sine theta. And by the way, we can find sine of theta from here, because we have 80 from law of cosines. We can find sine of theta to be 6 over root 205. That's what it simplifies to. Okay, this is really crucial information. So first of all, we have x over sine theta. We know what sine theta is. Then we have, so the sine of BEA, as I said, was the sine of the sum of these two. And we have this, you can calculate it using, the sine angle sum of these two right triangles. Anyway, the sine goes in the bottom. And we have the side opposite it, this side is 13, which is why it's the simplest ratio to choose. Okay. Next, we have sine theta, which makes this a lot simpler. And we can substitute in. Wait a second. Never mind. Wait. Oh, I nearly put this in. Sorry. We have 6 over root 205. Something's wrong. Oh yeah, sorry. We have to find the sine of this angle, which is a sine sum of these. So it's going to be sine theta cosine b, sine theta cosine b, plus cosine theta sine b. Okay, so this is sine theta, and then cosine b is going to be, you can use the Pythagorean theorem to find the cosine, and difference of squares makes it easier. Okay. This plus, and then Pythagorean theorem, that gives you 205 minus 36, what's really 13? Yeah, okay, 13 over 205. Thank God it's an integer. We have, and then you have the sine. Yeah, basically just use this sine of the sum of these two angles, theta and b. And we will find Alright, wait a second. We had x over sine theta. X over sine theta equals hold on. Okay. X over sine theta equals 13 over the sine of this. 13 over the sine of this. If you take the reciprocal of the both sides, though, you get the sine over 13 is equal to the sine of theta, which is 6 over 205, over x. Right, we don't do this anymore. And if you simplify that, this is basic multiplication. Yeah, you can cancel out to 13, but here you can't, which is why you can't use a common denominator. But we can multiply both sides by root 205. That'll help. And then take the reciprocal, multiply it by 6. And if you factor it, you'll get this. Basic algebra from here. Okay. And the reason I did that, because it asks for q, the denominator, and be. So we need to check that this is not, this is relatively prime to the numerator, not make a final mistake. Alright. So, since if you factor it, you get 13 and 15. Here, this is not divisible by 3, this is not divisible by 5, and it's not by 13. You can quickly check that. And that gives the simplified denominator, final answer of 463. It took a lot of attempts to film this, so I really hope you savor this and learn from this video. Basically, yeah, if you use the wrong root in law of sines, you'll get to a dead end in almost every single way. But okay, using law of sines and then repeatedly returning to these triangles and looking at manipulative identities, that's what helped you get the answer. I hope you learned something new, and thanks for watching.